All right, so now we've talked about applying our exponent rules with multiplication, with products. We are now going to look at quotients, and a quotient is when division is involved. Okay, you've got a power, the property for quotient, power, I'm sorry, let me say that again. Quotient of powers property. So when a quotient is involved, and this is a little bit blurry, I don't know if you can see that, but a to the m divided by a to the n. What we do with our exponents in this case is we subtract. Okay, we're going to subtract the exponents. Okay, so if you think about it, that makes sense. When we multiplied, we added the exponents. So when we divide, we're going to do the opposite. We're going to subtract the exponents. So here's a few examples for that. And again, the base has to be the same. So this rule only applies when the base is the same. So I have 10 to the 8th over 10 to the, 8 to the 10th over 8 to the 4th. Okay, the base is going to stay the same, and I'm going to subtract the powers. 10 minus 4 is 6. Okay, here's example 2. The base is the same. They're both -3. So the base is going to stay the same. Notice the base is in parentheses in both cases, so I'm going to leave it in parentheses. And I'm going to subtract the exponents. 9 minus 3 is 6. Okay, we're going to begin to, not only are you going to see quotients here, but you're also going to have to apply all the rules that you learned with products as well. In the numerator here, we have a product, so we're going to apply that rule that we learned last time. Base is the same, so I keep the base, and I add powers. 4 plus 8 is 12 over 5 to the 7th. Now I can apply my rule for quotients. So base is the same, so I keep the base, and I subtract my powers. Okay, when we have a fraction involved, remember we would work with fractions just by taking this x to the 6th and putting a 1 under it, and I can multiply terms straight across. This would give me x to the 6th over x to the 4th. Now I can apply my quotient rule. So the base stays the same, and I'm going to subtract my powers. 6 minus 4 is 2. Okay, I'm going to put 7 to the 9th over 1, and I'm going to multiply straight across. So I take the two fractions and I combine them into one fraction. And then I'm going to leave the base the same, and I'm going to apply the rule to subtract. Now the reason that we can subtract, okay, is 7 to the 9th. The reason why this works, 7 to the 9th means that I have 9 of these 7s. Is that 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Over, I've got 2 here on the bottom, 7 times 7. So if you think about how a fraction works, we would be canceling these out. Canceling these out. So how many would be left? Okay, well, there'd be 7 left. That's why our answer is 7 to the 7th power. Okay, we're going to be applying different rules. It says a power of a quotient property for all numbers, a and b, where m, all numbers, let's see, for all numbers a, b, and m, where a is not equal to 0 and b is not equal to 0. Okay, when we have a quotient that's raised to a power, we're going to distribute that exponent. So we're going to take the numerator and raise it to the power, take the denominator and raise it to the power. So for example, x divided by y cubed would mean x to the 3rd divided by y to the 3rd. We distribute that exponent to the numerator and to the denominator. I can't do anything more with this because the base is not the same. I've got a base of x and a base of y. They're not the same, so I cannot subtract the exponents. It's going to be equal to, first of all, it's a negative fraction and it's being squared. What happens to the negative when I square it? Well, it's going to become positive, and it's going to be 7 squared over x squared. Okay, that'll be 49 over x squared. Okay, we're taking this numerator and we're raising it to the 3rd power. Well, this is a product, so this goes back to the rules we learned before. With our product, we are going to take the coefficient, or the 4, and we're going to raise it to the 3rd power, as well as x squared to the 3rd power. That's going to be x to the 6th over. We're going to do the same thing down here. This is a product, so we have to take 5 to the 3rd power and y to the 1st to the 3rd power. I'm going to clean this up a bit. 4 to the 3rd power, 4 times 4 times 4. That's 64 x to the 6th over 5 cubed. 5 times 5 times 5. Okay, if 64 and 125, if they had a common factor, I could reduce that fraction. I don't believe that they do, so that stays. And then these don't have the same base, so we leave those as is. Okay, again, we're going to take the numerator and raise it to the power. So that's a power raised to another power. We multiply in that situation. This is b to the first raised to the fifth. I would leave my answer like that. Okay, if it's a negative fraction and you cube it, you raise it to an odd exponent. That'd be a negative times a negative times a negative. Well, that fraction is going to stay negative. 5 to the third over y to the third. I would ask you to simplify y to the third. This would be a negative 125 over y cubed. Okay, we got a power raised to a power. That's x to the fourth over. So it'd be 4 squared, y squared. We'd want to simplify that. 4 squared is 16. Okay, a couple other examples down here we'll do, maybe the bottom two. If we've got fractions that are being multiplied, we would want to take care of the parentheses first. So this parenthesis is raised to the third power. Let's get that first. That would be m to the power raised to a power. We multiply. And then it would be n to the sixth. This fraction doesn't have anything going on with it, so we leave it as it is. Now that we have second one simplified, we're going to multiply fractions straight across. Multiply straight across, I get 3m to the 12th over 8m to the 5th n to the 6th. Okay, now you've got a common base here between these two, so we're going to go ahead and we're going to subtract. We get m to the 7th. Okay, I've got an 8 in the denominator, n to the 6th. So I'd say my final answer is 3m to the 7th over 8n to the 6th. Okay, maybe just do this one up above it. Okay, if I've got parentheses right here, I need to do parentheses first. So that would become x to the 21st over y to the 7th times 1 over 3x to the 8th. When we multiply fractions, we multiply straight across. So I get x to the 21st over 3x to the 8th, y to the 7th. I always list my variables alphabetically. And then I've got a common base here. So I'm going to say that equals, if I subtract my exponents, I get x to the 13th over 3y to the 7th. And that would be my final answer there. Okay, you got a worksheet that you can work on where you are applying not only the quotient rules that you just learned, but you're also going to encounter some of those product rules as well.